So finally, we want to look at the rules for simplification. Rules for simplifying complex numbers. It's not really rules, it's actually rule for simplifying complex numbers. The rule is this. Always convert everything that you can to I, or I's, as soon as you can. And honestly, it's kind of that simple. If you convert everything that you can to I's as soon as you think that it's possible, it's actually quite nice. The numbers look better, you get rid of the negative signs right away, just makes things in general happier. So if I see something like this, it's also algebraically critical. So if I've got something like this, negative square root of 25 times, square root of negative 25 times the square root of negative 4. I want to convert everything I can to I's as soon as possible. Not only does this make it easier because now I don't have these stupid negative signs running around that just make life miserable, I'm actually going to get an algebraically correct answer, which I wouldn't the other way. So if I've got a negative 25 on the inside of a square root, I say, well, I got a negative sign. Remember we did this earlier. Negative sign, I can make that be an I. So what I have left is 25. On this other one, I got a negative 4. Negative 4. So I can make that an I, and then the guy who's left is just the square root of 4. So once you pull out the I, you can drop the negative sign on the inside, which is really fantastic, right? All right. So now I've got I times square root of 25, which is 5, times I times the square root of 4, which is 2. And again, because, A times B times C is the same thing as C times B times A, or A times C times B, or whatever. We can switch the order around, it doesn't matter. So we've got 10 times I is I squared. Remember, I squared is negative 1. So I've got 10 times negative 1, which is negative 10. This is the good way. Good way. Now, we're going to look at the bad way. Ooh, are you scared? You should be, because this is actually something that drives me nuts. Because this is what I always want to do. I always want to say, oh, dude, check it out. I'm super awesome at algebra, and look how awesome I am. I can say negative 25 times negative 4 is the same thing as square root of negative 25 times negative 4. Yeah? Nope. Not equivalent, actually. Not equivalent at all. This is bad, 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 bad. Break your heart bad. The reason for that is that I didn't do my one cardinal rule was to convert everything I can to I's as soon as I can. I could have made these I's, but I didn't listen, and now look at the trouble I'm in. Because negative 25 times negative 4 is positive 100. So what's just happened is I've lost critical information. This negative sign and this negative sign are gone forever and ever and ever and ever. Square root of 100 is 10. So I got an answer of 10, when in reality, the answer is negative 10. This is the good answer. This is the bad answer. Okay? So it's very, very important that you simplify everything that you can to I's as soon as possible. Okay? Like I said, it also makes things a little bit easier because you can do things like this. So say I had the square root of negative 18 minus the square root of negative 8. And that's pretty hideous, right? I got negatives everywhere. I don't know what to do with negatives. So I say, you know what? I'm not going to worry about it. I'm taking it a step at a time. I'm going to do the one thing I know how to do, and that is I can get rid of those negative signs. I can get rid of the ones that are inside the square roots. So I've got negative square root of negative 18. I can pull that negative out and make it I with the square root of 18 left over. This negative I can't do much about yet, but here I've got negative inside the square root sign, so negative can pull that out to be an I, and then who's left but the square root of 8. Now let's take a quick aside over here and make sure we got this down. What's the square root of 18? Remember, I can break it up into square root of 9 times 2, or 3 square root of 2. And then the square root of 8 I can break down into 4 and 2, or get 2 root 2. Okay, so I can actually use that. I can get I times, we said square root of 18 was the same thing as 3 root 2. And then I, and we said the square root of 8 was the same thing as 2 root 2. And because we are quite clever, and we realize that, again, what's that thing called? Multiplication is flip-aroundable. I can, essentially, I've got I times 3 times the square root of 2, and then I times 2 times the square root of 2. I can rewrite that as 3I square root of 2 minus 2I square root of 2. So actually what I have here is I have 3I square roots of 2, and I'm subtracting 2I square roots of 2. So I have 3 of something minus 2 of something, and in the end, 3 of something minus 2 of something is the same thing as 1 of something, 1 of I square roots of 2. But I don't actually need that 1 because I'm ultra sophisticated and I know that the 1 is just a placeholder. So I got 1 times I squared root of 2, but that's really just the same thing as my more subdued and elegant I root 2. In a problem like that, my solution would just be I root 2.